This is CAD Design Software's demonstration of hybrid MCM. Once you start a CAD Design Software, you'll be prompted to read a technology file. Technology files set up the design environment for measurements and layers. For schematics, we don't need a technology file, so we'll hit cancel. And next what we're going to do is we're going to open up our sample schematic demo. This is our schematic of the physical layout. After this schematic has been done with the auto schematic capture program, we'll generate a net list so we can get the parts and the net connections for all of the different nets that are involved. So we'll go to the CAD Design Software, Schematic, and we'll initialize the schematic environment. Once the environment is initialized, we'll go to the schematic capture menu and we'll go to the capture netlist command. We'll go ahead and pick the build button and all the parts and packages are captured in the design and all the nets, including the power nets. Then we'll save this net list to our current working directory. We'll accept the default name. We'll be prompted. And we'll be using this net list later in the physical layout to compare all of our net connections. We'll pick exit. And now we can close this drawing. Next, we're ready to start our physical layout. We'll do a new design drawing. We'll do a file new. Press enter. We'll select the CAD Design Software preset, the hybrid 4NL 1FL inch technology file, and pick open. Now we'll immediately save. File save as. We'll save it as hybriddemo.dwg. Now we can review our technology settings. Go to CAD Design Software, Technology Preferences command. At the top we can see that we're using the current technology file that we had selected. We have default values. We're using a hybrid type design. We have 4 layers, 1 bottom layer. Our layering scheme is set. Our trace width for the global traces are set. We have our global clearances set. Our layer types have been set up for our signal and plane nets. Our global text sizes have all been set for the various attributes that appear on each part. And we're going to set our global snap to 0.005. Then we'll pick OK. Now we'll run our LX command. We'll type LX and enter. We're going to switch the file to hybrid demo layers.lx. Pick open. And these files are preset drawing setups for all the various artworks. This will be used later on during the physical layout. Now that we have switched our file, we'll just hit cancel. And now our design environment is all set up. In our next section, we'll start making the die outline patterns. We'll go to the CAD Design Software, Hybrid menu, and we'll pick the die make command. We'll set our values manually. And our die length, 0.08. Die width is 0.08. Our pad length will be set to 0.02 and width is 0.02. The side parameters area in the number of pads in side 3, we'll set that to a value of 2 and press enter. Then we'll set our pitch to 0.05, and our inset will be set to 0.04. Then we'll pick the Create button to create the die. It'll ask us for an insertion point. We'll press Enter to accept the default of 0, 0. Then we'll be prompted to select a pad to be assigned pin number 1. We'll pick the upper pad. The die creation dialog box reappears, and it'll ask us to either make some additional modifications. We're going to make a new library, and we're going to call it HYB demo, and pick OK. And in the die name edit box, we'll type in die 1. We'll also select the Save Parametrically Created Entities Only checkbox, and then we'll pick the Save button. We'll run our die make command again from the hybrid menu. And we'll make another die. In our die length, we'll set that to 0.1, and we'll set the width to 0.15. We'll set our pad length to the original value of 0.02 from the last die that was created. In the number of pads area, we'll set side 1 to 3 and press Enter. And we'll set side 3 also to 3 and press Enter. And in our pitch area, we'll set 0.05 and 0.05. In our inset area, we'll set this to 0.02. We'll pick the Create button. Asks us for an insertion point. We'll press Enter again. And we'll be prompted to select pin number 1. We'll pick the upper pad in the first column here. And then we'll save this as well to the same library, and we'll name it die 2. For our third die, we'll read in an LIQ file. We'll run the die make command. In the LIQ die file control, we'll pick the Read File button, and we'll use the die3.liq file and pick Open. We'll be prompted to pick an origin. We'll just accept the default of center, press Enter. Our insertion point, we'll accept the default of 0, 0, press Enter. We could see our die, pick the Exit button, and review the die that was made in LIQ form. And then we'll save this as die 3 into the same library. Now that all the dies have been saved into a library, they'll need an attach pattern. Next, we'll use the attach command to read in the die outline patterns and apply the bound wire fanouts. We'll hybrid menu, we'll pick the attach command, and the last library that was just saved in this current drawing session will come up automatically. We're going to start with die 1, so we'll pick the Use Selected Die button. Ask us for an insertion point, we'll press Enter. Rotation is 0, Enter, and we'll press Enter to continue. We'll be prompted that there are no parameters. This is standard because this die has no saved parameters. We'll pick OK. We'll start at the top here in our substrate bond pad pin size, SBP, and we'll set that to a value of 0.005. In the die bonding pad control area, we'll include a die bond pad. In our fan-out types, we'll select a fan-out type of straight aligned. Just above that, in our bond wires area, in the inner row box, we'll type in a value of 0.1. In our pad shape area, we'll pick the Set button to set up our pads. We'll make sure we have rectangle selected, and we'll accept the defaults 0.014, and our pad width will set to the same. And we'll pick OK. In our fan out parameters area, we'll set our pad to pad gap value to 0.014. In our information window down below, we're going to select both of these pins by holding the control key to select multiple. Once they're selected, we'll pick the Edit Selected Pins button, and we'll make sure that this is set to the L1 group for a left side fan out. We'll pick OK. Now we can see over here in the information window they've been upgraded to a group to L1. We'll pick the Calculate button, and then we'll pick the Add Pads button. We can pick OK to go look at our temporary pattern, and press Enter to return to the Attach command. In our Attach Name edit box, we'll type in a name for this new pattern. We'll call it Die 1A, and we'll pick the Save button. We'll return to our Attach command to do our other second die 2. We'll select die 2 and pick Use Selected Die. Press Enter to accept the defaults. In our bond wires area, we'll set the inner row to 0.06, and we'll set our pad shapes up. We'll set our pad shapes to 0.02. Then we'll pick the Calculate and Add Pads button. We'll call this Attach Die 2A and pick Save. We'll return to our Attach command. We'll pick die 3 and we'll use Selected Die. Accept our defaults. We'll set our pad shape up. We'll set this back to 0.014 and pick OK. In our fan out parameters area, we'll select the pad to die checkbox instead of using the inner row value, and we'll set our pad to die to 0.045. We'll set our pad to pad gap to 0.01. Then we'll pick the Calculate button and our Add Pads button. Pick OK. We'll return to our Attach command, and we'll save this as die 3A. Pick Save. Now all of our attached patterns have been saved into a library and are ready to be placed into the physical environment. Next, we'll create our boundary outline on the PCB layer. We'll type in the command PCB edge and press Enter. We'll accept R for rectangular as the default. We'll press Enter. And we'll put in our values. We'll select a corner for the base point. We'll accept the size as 0.1, and it will be placed on the PCB layer. We'll pick OK, and now we have our base outline. Next, we'll use CAD Design Software's parametric part libraries to create and place parts. We'll go to the CAD Design Software, PCB menu, Parts, SMT, and we'll pick PLCC2. In our block name, we'll type in the name of PLCC20. We'll select the Assign RefDes checkbox and pick New and create a new reference of J. We'll select our side N3 to place our component on the N3 layer, and we'll suppress the silk screen. Next, we'll pick our Edit Parameters button to customize our component. We'll set our length and width of the pads to 0.08. We'll set our pattern length and width to 1. We'll set our number of horizontal and vertical pads to 6. In the pin 1 land size area, we'll select normal. In our center to pad center distance, we'll set 0.12 and 1 and 1 for the component length and width. We'll pick OK. And we'll pick the Create and Block button. And we'll type in a value to place this component, 0.5, 0.5. We'll press Enter to exit the command. Type Z, E, and Enter for zoom extents, and we can see our component outline. Next, we'll place our attached patterns that were saved in the library earlier. We'll go to the CAD Design Software Hybrid menu, and we'll pick the Place Attached command. We'll select our library, Hybrid Demo, and we'll select Die 1A. In the side pop-up list, we'll set this to N2, and our substrate bond pad layer, we'll set that to N3. We'll assign a reference designator of Q1, and then we'll pick the Place button. We'll place this by coordinates, 0.79, 0.21, and Enter. We'll repeat our Place Attach command by pressing Enter, and we'll select Die 2A, and we'll set its side to N2, and its substrate bond layer to N2. We'll assign a reference designator of U1, and we'll set our angle to 90, and we'll pick Place. We'll type in our coordinates, 0.755, 0.61, and Enter. Press Enter to run the Attach command again, the Place Attach command. We'll select Die 3A. In our side, we'll select N1, and SBP will also be on N1, or N2. And reference designator will be automatically assigned to U2. We'll pick Place and type in our coordinates, 0.315, 0.505, and Enter. Now all three attached patterns are now placed and blocked in the drawing. Next, we'll create our cavity keep out outlines for each one of the attached patterns. We'll go to the Hybrid menu and pick the Cavities command. In the block name, we'll type in Cav1. We'll uncheck the Assign RefDes checkbox, and we'll pick the Edit Parameters button. We'll have two cavities for this one. We'll type in a length of 0.25 and a width of 0.3. We'll set our values, 0.049, 0.049. Corner radius will be 0.005, 0.005. And our trace keep out outline offset will be 0.01 and 0.01. Then we'll pick OK. In the side pop-up list, we want this to be placed on the N2 layer, and then we'll pick the Create and Block button. We'll type in our placement coordinates, 0.315, 0.505. Press Enter, and Enter once more to exit the command. We'll create the additional two cavities. We'll run the Cavities command. We'll set this one to Cav2, and we'll edit the parameters. We'll set this number of cavities to 1. Our length will be 0.21 by 0.24. We'll accept the values from the last cavity created. We'll pick OK and Create and Block. I'll type in our placement coordinates, 0.755, 0.61. Press Enter once more to exit. Then we'll run one more cavity. type this in as CAV3, and we'll edit the parameters. We'll set the length on this one to 0.13 by 0.13 and pick OK. And we'll set the side on this one to the N3 layer, and we'll pick create and block. We'll type in our placement coordinates of 0.79, comma 0.21, and press enter to exit the command. And now we have our cavity keep out layers and outlines placed. Next, we'll place some additional components from the libraries. We'll go to the PCB parts menu, SMT, and we'll pick the SM chip command. We'll pick the select part from parameter library button to pick a part from our libraries here, and we'll pick use selected code. We'll use code 1. We'll make sure our side is set to N3 to place a component on N3, and we'll make sure suppress silkscreen is currently checked. And we'll pick create and block, and we'll type in our placement coordinates 0.435, comma 0.8, and we'll place another component at 0.61, comma 0.8, and press enter to exit the command. We'll type REFDES for refdes, and we'll press enter. And we'll type in C3 and select our component here, and we'll select change C and type in C5 and enter. We'll select our component here. Press enter to exit the command. Next, we'll create a top hat resistor. We'll go to the hybrid menu and pick resistors and pick the resistor command. In the block name, we'll type THKRES3 for thick res 3. Make sure our pop list is set to N3. Pick the edit parameters button. In the resistor type, we'll pick a top hat for the resistor. In our resistor specification area, we'll make sure it's 100 ohms. We'll press enter. We'll pick the overglaze checkbox and type in a value of 0.01. And in our leader length edit box, we'll type in a value of 0.0595. And we'll pick OK. And we'll pick create and block. And we'll type in our coordinates, 0.565, comma 0.365. And enter. We'll type R and enter to rotate. Type in a value of 270 and enter once more. Now that all of the parts are placed in our drawing, we can move on to start defining vias and routing the drawing. Next, we'll define some vias in the drawing to be used during the routing process. We'll go to the CAD Design Software hybrid menu, vias, and we'll pick the hide via command. We'll select the rect radio button for a rectangular shape, pick the Alt 1 for our stair step type. We'll pick the thick film radio button, and we'll pick the through hole parameters button. We'll pick the gold plug, and we want to uncheck include, and we'll do the same for the del top and del bot. So all we have left is the hole for our through hole via creation type. We'll pick OK. In our layer 1 and 2 area, we'll select the type of stair step via we'd like. We'll have this starting on the N3 layer and ending on the F1 layer. In our net name edit box, we'll type in G for ground, and then we'll pick OK. The prompt will let us know all the settings it is ready to place. An insertion point for the via. We'll just place it off to the side of the drawing to define it within the block tables. We'll type D and enter to define another via, and this time we'll select the N2 starting layer ending on F1. We'll just pick OK. We'll place this one off to the side. We'll type D and enter once more, and we'll select the layer starting N3 to N1. We'll take out the G in the net name, we'll press delete, and then we'll press OK, and we'll place this via off to the side as well. And you press enter to exit the command, and now our vias are defined in the drawing. We can now erase these since the block definitions are now resident in the drawing. Zoom extents. In our next step, we'll read in the net list to create all the connections between our components. We'll go to the CAD Design Software, PCB, Net menu. We'll pick the net read command. We'll select the hybrid demo schematic.net, which was generated from our schematic. We'll pick open. The nets will be read into the drawing. Now we'll create the rat line connections that can be converted into conductive traces. We'll go to the net menu, pick the rat command. We'll receive a box that new nets have been added because we read in the net list. We'll say yes to turn them on. And our rat drawing control dialog box appears. All of our nets have been read in. Let's color the ground net to green so we can see it better when it is drawn, as well as our other power net. We'll set this to a red, and then we'll select draw rats. All of our connections are now set for the pins. And we're ready for the next step. Next, we'll use the tie via command to automatically create ground ties on the ground nets on multiple layers. We'll go to PCB, ground. We'll pick the tie via command. We'll accept our global trace width and pad-to-pad clearance values that were set in technology. In the slide window, we'll select these blank areas to add these ties to the pad, so it will place ties on all available sides of a pad. Then we'll select our via for layer N3. We'll use the N3 to F1 via with a G net. And for layer 2, we'll use the N2 F1 via. Now we'll pick the Select Nets button. We'll select the available net, which is G for ground. We'll move that to Nets to Receive Ties. Pick OK. Now we'll automatically place the ties on the selected nets only. The program will scan the drawing and follow the ground net and place the appropriate ties. Then we can zoom in and see our ties. We turn our fill mode off, type FM and enter. Next, we'll use CAD Design Software's routing tools to convert the rat lines into conductive traces. First, we'll turn off our object snap, type ON and enter. Then we'll set up our layer views so we can see the appropriate layer to route on. We'll use the LX command, LX and enter. I will select the TN3 for trace layer 3 and pick OK. And we'll go to the PCB route menu and select the track command. At the prompt, we'll type C and enter to configure. And we'll uncheck layer pairing since we're only routing on one layer. And we'll pick OK. And we'll zoom into the area of C5 and R1. And we'll select on the route line. The additional ring that appears on the outside is the clearance checking envelope. So we'll pick a point here and downward a little. And we'll type T to terminate to its corresponding pin. Do another route. Pick down here. I'll drag all the way up here. The clearance envelope will not let us because it is violating. So we'll pick in a little more. That should do it. Then type T to terminate. We're going to intersect a route into this conductive trace, since it's part of the same net from the R3 pin 1 connection. We'll select on the rat line. We'll put it right on top of the trace here, select a point, and then we'll type M to complete. And it will break into the polyline itself. We could press enter to exit the track command. And if we type FM and enter to turn off our fill mode, we can see that the conductive trace was broken into this route. So now it is part of the same net. In our next example, we'll show routing from the N3 to N2 layers. We'll set up our layer viewing artwork using the LX command. We'll select the TN2 and TN3 artworks to show. And we'll go to our track command, and we'll type C and enter to configure. We'll enable layer pairing this time, and we'll select trace N3 and trace N2 as our layer pairs. We'll pick OK. And we'll zoom up here to pin 19 and pick on the rat line. Drag out a point here. We'll type L. We'll be prompted to place a via. We'll select the via must start and end at active layers radio button, since that was set up in the track configuration dialog box. So the only available via will be the N3 to N2 via. We'll pick OK. And as indicated in the bottom left corner, L equals trace N2, showing that we're now routing on the trace N2 layer. So we'll route out a little bit here, and we'll type T to terminate. For the next example, we'll show more internal routing and using multiple nets. We'll run our track command, type C and enter to configure. We'll enable layer pairing so we can manually select the routing layer we want. We'll pick OK. And we'll zoom down here to J1 pin 8, pick the rat line. We'll drag out a little ways here, pick a point and type L. We'll be prompted to select the routing layer now. We want to select layer N1. It'll also prompt us to place a via. We want to use the Alt 1 with no G for the net, and pick OK. Now, as indicated in the bottom left corner, we're routing on trace N1. Now what we need to do is orbit the cursor around a little bit. So what we'll do is we'll type B twice to orbit outward, and now we're ready to route. We'll pick a point right around here and downward. When we get to the point near the end of the destination, we'll pick a point and type L, and now we'll select the trace N2 and the via, pick OK. Now we can type T to terminate. To finish off this multiple route, we'll select the additional net within. We'll pick, and we'll type T to terminate. Now we've combined two nets and we've routed on multiple layers. Next, we'll create crossover route traces using the dpatch command. We'll go to the CAD Design Software PCB route menu and we'll select the track command. Type C and enter to configure. We'll take off our layer pairing and we'll set our clearance checking to off and no flags. And we'll pick OK. We'll zoom into the area here between R4 and C4. We'll pick our traces to route using T to terminate. Then we can press enter to exit the track command. Then we'll go to the CAD Design Software hybrid menu, dielectric, and pick the dpatch command. In the dpatch dialog box, we'll set up some values here. Type 0.01, 0.01, 0.005. Then we'll pick OK. Then we'll be prompted to select the trace to receive the upper level bridge. We'll pick the trace here. Then we'll be prompted for the lower level. We'll pick this trace and we'll press enter. The dpatch is now created and a new trace has been created on the upper layer. We'll open up our layers. TRAN4. Now we have our dpatch crossover. In our next example, we'll create a boundary net from a zero width closed polyline. This boundary net will encapsulate the pins on components so it can be captured during the netlist generation. We'll set up our view, LX, and enter. We'll set our trace layer to TN3. We'll zoom in toward the upper portion of our design here. We'll set our working layer to trace N3. Set our snap to a value of 0.01. Then we'll type PL and enter for the polyline command. Pick a starting point. And we're going to create a boxed net encapsulating the pin on these certain components. And as we approach the original starting point, we'll type C and enter to close. And now we have a closed boundary polyline. This is also considered a conductive trace, such as the ones we routed earlier. CAD Design Software allows a zero width polyline as long as it is on the appropriate layer. Next, we'll create a ground edge and do a positive pour for our conductive layer. We'll set up our artwork first. We'll type LX and enter, and we'll select the AF1 code. Then we'll go to the PCB ground menu, and we'll select the GND edge command. We'll set our edge air gap to a value of 0.03, and our edge width will be 0.0. The command will automatically create the ground edge on layer GEF1. Pick OK. We prompted to pick the edge. We'll select the PCB outline, and the ground edge will be created on GEF1. Next, we'll go to the PCB ground menu and we'll pick the pour command. We'll be prompted to turn off our PCB layers, and it is not necessary for a pour. We'll say yes to go ahead and turn it off. And the copper pour control dialog box appears. We'll select the positive boundary radio button, and in our layer control area we'll make sure that the fill hatch layer is set to GP for ground plane F1. We'll set our angle of hatch to 45 and we'll pick the pour button. It will be prompted to pick the plane outline. We'll select our ground edge and the plane is created. We'll create one more pour for our N1 ground plane. We'll use our LX code. We'll select the AN1 artwork layer and pick OK. We'll use our ground edge command to create the ground edge. We'll accept the defaults of the last known positive plane ground edge. This one will now be placed on GEN1. We'll pick OK and select the outline. And then we'll run our pour command. In our copper pour control dialog box, we'll select the by reference net names radio button and ignore pads. We'll set our air gap values to 0.01. We'll still use a angle of hatch of 45 degrees, and then we'll pick the pour button. Select the plane outline, and the boundary is now created. Next, we'll use CAD Design Software's net checking tools to check the net list on the drawing, check net connections, plane continuity, and compare to a reference net list. We'll go to the PCB net menu and pick the net check command. We'll select the G plane nets and we'll set that to default. In the shape-based capture area, we'll check plane continuity and capture the full copper. Then we'll capture the PCB net list. Next, after the net list is captured, we'll compare the PCB net list to our reference net list, and we'll use our schematic net list generated from our schematic design. Pick open. After the comparison, we'll pick the Analyze Errors button to see if there was any errors. If we have an island error, we can select it and zoom to the error. We can, at this point, we can type D and enter to delete. We can erase any additional little islands. Go back to the net check command and we can pick recapture. We'll capture the PCB net list again. Analyze the errors, and no more islands. We'll pick OK. Turn on all of our layers. Next, we'll use CAD Design Software's DRC, Design Rule Checking tools, to check for any clearance errors. We'll go to the PCB check menu. We'll pick DRC. Pick the Set Clearances button. Won't need any extra settings here, so we'll hit Set. We'll pick both Standard Objects buttons. We'll specify our minimum clearance to 0.01. We'll set the specified value. We can see all of our settings now. We'll pick OK. We'll pick OK once more. We'll pick the Run DRC button. We'll encapsulate our entire drawing and press Enter. We'll return with a number of errors found. Pick OK. Then we can type VE and Enter to view our errors. We can pick on an error, double pick, and we can see any clearance errors. Some clearance errors can be accepted according to your own design rule specifications. Next, we'll create the dielectric offsets for the hybrid vias. We'll go to CAD Design Software, Hybrid, Dielectric, and we'll pick the D-via command. We'll type in the value of 0.002 and Enter. And we'll be asked to regenerate the screen to see the offsets. Type RG and Enter. Then we can use our LX command to view the different dielectric layers. Use DN1, DN2, DN3, and turn all of our layers back on. To view the newly outputted Gerber code, we'll start a new drawing. We'll do a File New, press Enter. We'll hit Cancel on the Read Technology file since we'll just be reading in the Gerber files themselves. We'll go to CAD Design Software, Conversion, GerbARX, GerbView. We'll select our master aperture file. It'll refer to the current working directory. We'll use the hybriddemo.rep file and pick Open. Then we'll pick the View button to generate the Gerb view. We can run the Gerb view command again, and this time we can pick on layers and isolate them to view them individually. We can also color the layers by double picking them and selecting a color from the list. And this concludes our hybrid MCM demo.